So for those, can everybody hear me? Because I don't want to hold this up if I don't have to. Kind of? Yeah, good, okay. For those who don't know me, I'm Justin Meyer. I work for Bitovi. We do JavaScript consulting. So you can email contact@Bitovi if you need that kind of stuff. Today, I'm going to talk about hopefully something you'll be using maybe in a year to start a project. I'm going to be talking about the ES6 module loader specification. It should be finalized towards the end of the year. Browsers, there's really good polyfills already, so hopefully, browser vendors can start putting it in really quickly. I'm going to go through how we load scripts, how we used to load scripts, how we load scripts now, or deal with module management. I'm going to go through in detail what ES6 provides. I'm going to talk about a dream project that I've kind of started to build that tries to solve, in some ways, all of the challenges of module loading, and then go through the technology that I used to build it. So, loading scripts. How is it done? We're all familiar with this, adding script tags to the page with all your modules. And then in something like app.js, which loads last, you'll use modules, or not really modules, but functionality added to the global window that your other scripts provided. Now, who still does this here? They just have a bunch of script tags? Not somebody? Kind of? Really? Okay. I'm looking at the cars, folks. It'll be sad. So this is just fraught with a lot of problems. If let's say login ended up, your login page needed tabs.js. Well, you'd have to flip the order. You'd always have to be kind of maintaining what's in what. If anything used the same name, you're in a whole bunch of trouble. But that's how you do static loading with just script tags. And then to do dynamic loading, you want to load something progressively. Create a script element. There's a few ways of doing it, but one of the more common ones. Create a script element, tell it where to load, add an onload handler, which contains kind of your kickoff functionality, when that script is loaded, and then add that script to your page. So today, how many people are using AMD? Some form, require.js, probably a third, maybe more. So with AMD, there's a bunch of different ways you might have a setup, but you typically, excuse me, just drink Coke. So you add a script tag to your page, sometimes for configuration, right? You a lot of times have to configure AMD or require.js to tell them where to load certain things, how to load it. And then you load require.js and you'll tell it kind of the entry point, what module to load. And then in your app module, you will basically tell require.js what modules to load, so login and tabs. When those have loaded, this function will be called back, and you will create those modules and do something with them. And then your configuration that you might load might do something like this. You don't have to shim jQuery. I'm just showing an example. You can put this in your page, and then AMD or require.js will know, hey, if I load jQuery, I'm going to look for window.jQuery, and that's going to be what jQuery exports. That's what's going to call back if I were to require jQuery. For dynamic loading, it's really easy. With require.js, you just require your module sometime later, and it will load that module and all of its dependencies. Who uses CommonJS/Browserify? Here, okay, fewer people. So with that, you basically are going to point your page to some JavaScript file that Browserify is going to build for you. Somewhere else in your app.js, you'll use CommonJS to require your modules, and then you will use them like this. But if you have configuration, there's browserify shim that you can use and put in your package.json, and that can configure things like telling jQuery, which might not be using CommonJS to do what it exports and things like that. So it can be used. And then you'll build that module to some output file and load that. So one thing I didn't include here with browserify is how you do progressive loading. It's not super straightforward. You kind of go it alone. So there's some pluses and minuses to everything that I've kind of put between the different approaches, kind of more modern approaches. Is anybody using anything else, by the way, like that I didn't?
I was looking at Webpack. I was looking at Webpack.
Oh, Webpack, yeah. That's kind of an emerging something similar to what I'll be showing off today. So there's kind of pluses and minuses. So CommonJS is great if you're doing CommonJS and browserify because you have NPM, and it's very easy to add things to your current project, package them up, and send them to the client. Kind of forces you to build, which is a good thing, but I also have it as a minus. With browserify, you can't just, I can go to a JS fiddle right now, load require JS on the client, and then hit other people's CDNs and just use require JS. Right? I don't have to host or build or do anything to use require JS. So that's really a big advantage. I find require JS syntax a little less than ideal compared to CommonJS. And some of the biggest difference in terms of just use, how nice CommonJS can be versus require.js is require.js can only try a single place when loading the script because it makes an AJAX request and it either finds it there or it doesn't and gives up. CommonJS, it will keep walking up folders until it finds your module. And that's really nice. So it's a little bit less, require.js requires a lot of config, browserify less so. So, what's coming though? So we've got these two popular module formats already, AMD and CommonJS. Well, there's a third coming, and this is ES6 module loading syntax. So it looks like this. You can put a module element in your page and tell it which module you want to load. And then in app.js, you will use the import keyword to tell it what you want to import from. There's a lot more syntax that I'm going to go into in depth on how this works, but it's it feels a little bit more like CommonJS. And then for dynamic loading, ES6 will provide a system it's really called the system loader, and it has an import method that you can use to dynamically import modules. So here, system import, if I want to load the home page, that will return a promise that I can do then on. And if it's successful, I get my home page module. Otherwise, I get the error that it might throw. Okay. And then, by the way, if anybody have any questions at any time, just stop me. So, what does ES6 provide? ES6 module loader, really the spec provide. There's a few different technologies. The first is loader. And what this is an abstract kind of constructor where you can build your own loaders. Right? If you want to add your own custom behaviors to kind of what happens when a script gets loaded and have it independent of what you'll see next is the, whoop, I messed up my order, is the system loader. The system loader is like the default loader. That's a loader that's kind of loaded up with the ability to actually go get scripts and run them with ES6's syntax. Right? So there's the loader, which is like an abstract kind of generator, which will give you custom loaders. System is an instance of loader that's actually implemented all these hooks fully. And syntax, the syntax that it supports is that import and export syntax, which we'll see in a little bit. So going into each one of these in detail a little bit more, the loader construct. This has these 5 different hooks that you can implement to provide whatever rich loading behavior you want. So you can create a new loader and pass it a function to normalize, locate, fetch, translate, and instantiate. And basically what the loader module does is it's all the wiring between those things. So if I call myloader.import, it will first take jQuery, run it through the normalize hook, then once it gets like what actually module name it should look up, it'll pass it through locate, and then it will know the actual URL to go find that. Then it'll go to fetch, which actually retrieves the source for the module. Translate is the ability to, like, let's say you had CoffeeScript. CoffeeScript, you can do a CoffeeScript translation in here. And then instantiate is what actually, the instantiate hook returns the dependencies of that module and how to execute that module once the dependencies have loaded. So with Loader, you can do pretty much whatever you want. So here's an example. I could create a customized loader. Now you would never do this, but I just kind of want to show what some of these hooks look like. I want to make my own loader, and it has a normalized hook that if I ever write, like if I ever import bb/anything else, it's going to replace that bb with backbone, right? So I'm controlling what the name gets resolved to. This is how, like, you could implement like a map. If you guys are familiar with require.js's map config, you could do some code like that in here. The instantiate hook, this is kind of one of the more complex ones, but this is an example of how I could, if I was about to load some, or like actually run something that was jQuery UI related, I could make sure it depends on jQuery, and then when it comes time to execute that, I'm going to stick jQuery on the window and then remove jQuery after the source is actually run. That's how you might do the instantiate hook. So the syntax looks kind of like this. There's how you import and how you export. So this would import from math. So kind of with require.js, you can kind of import, you can just require, you just get the value of the module. With I guess you sort of, I don't know if I should be moving around. If you guys can't hear me, just let me know when I'm moving. With ES6, there's actually, like, you can have values on, this would import a maths add export and sum export, but it would alias it as total within the code body. But you can also have a default value. I'll show that in the next slide. And how you export is you just export, and if you have a variable like add, you just put it in there, or you can export directly functions or variables, that kind of thing. So here's the full syntax. So import, just a module name, that just will load the file but not add anything to your current scope. This would be good for like plugins. Like if you had a jQuery plugin, you would import that because it would be adding itself to $. Or like a CSS file. You can import the default value for jQuery, or you can import the $ export from jQuery. And you'll see in the next slide what I mean by defaults there. So here's the way you export. You can export, a default value is always going to be the value that you import without curly braces, but you can export other things that are kind of named exports. So it's this weird, like if you were underscore or something like that, it's a way that you can export all of underscore's methods that you can just import directly, and it can actually, like, on the fly build those if you wanted it to, or you can export all of underscore itself as the default value. It's really powerful and flexible, but that's what the default value is, and these other things are like named exports for that module. And there's a bunch of different, and these are how you do, so you can do exports as like values, or you can do export like, this would find an encrypt variable and export that. And you can alias variables in the kind of current scope. You can alias them in what you're exporting. And this would actually export, if I wanted to export everything from another library, like I was kind of passing through, I could do that like this. This would actually import crypto and export everything in it all within one statement. I don't know why you would do that. So what the system, so that there was the loader, which is the abstract class, and there's the system loader, which is an instance of loader that is actually implemented to do stuff. So you import something from system, it returns a promise. That promise, if resolved, gets called with that module value, and if there's an error, it'll get rejected, that promise. So the default system spec as of right now kind of supports two configuration values. One is base URL. So if you import it, if I set base URL equal to something on system and imported module, it'll look in kind of base URL's URL. Like it'll add to that the module, by default tack on a JS and go from there. By default, because, well, just take my word for it, it's by default. It's actually a little bit more complex than that. But it also is going to support the paths config. And this is, if you're familiar with AMD's paths config, basically the same thing. I want to look for Lodash, everything inside Lodash, inside util Lodash. So if I were to import Lodash map, it would look for it in the base URL plus this and find it there. Okay, so that's the kind of the basics that are the spec. Any questions here before I move on? Yeah.
Are there any kind of cross-domain considerations with importing things, or is it you just get scripts like you can with?
So there won't be there is with the polyfill right now, because it uses Ajax to do all of its stuff. Although there's a way to like get around that with system.js, which I'll talk about what system.js is. But no, it'll work, so you can go cross domain.
Nice.
Any other questions? Cool. Okay, so the dream. I want to have my cake and eat it too, right? I really want like the power and ease of kind of setup of CommonJS, but I want to be able to just run a page without having to build and have Node necessarily and things like that. I also want, so I have a checklist of things I want. And we're trying to accomplish with the project that I'm going to introduce, right? So I want to be able to use any module format, like whatever you guys throw it in. I want to be able to use that, right? And I want to pick one. I want faster builds, especially for progressive loading. I don't want to have to build, like I just said. We often, when we build applications, we have a lot of different like test pages that are each unique and independent. I don't want to like have to wire up like a page to be generated, or a JavaScript to be generated for that individual page. I just want to load it. I don't have to build every time. And I want to start being able to use ES6 syntax, right? Use the future today kind of stuff. So, I talked about what these mean. So yeah, use every format, I forgot. Use every format, use the ES6 sugar, classes, arrow syntax, default parameters, array comprehensions, all that stuff. I'm going to talk about this slide later, but this relates to how to optimize performance. So let's talk about the technology that I use. And at the end of this, I'm going to show a demo that like accomplishes all that stuff I just put up there. And this is the technology stack that I use to do it. These projects are a tracer, ES6 module loader, that's a polyfill ES6 module loader, system.js, Steel, Transpile, and Steel tools. And what each one of these do, tracer is a Google project, parses and transpiles ES6 to ES5. ES6 module loader is the loader and system polyfill that allows you to do system import kind of stuff. System.js is it basically adds to the system loader so that it can support AMD, CommonJS, and a whole bunch of other stuff. Amazing project. So we're added Steel, which is our client-side loader, which uses System.js to add, make certain workflow things a lot easier, provide plugins for CSS and less. We have a transpile project that will allow us to convert from AMD to ES6, ES6 to CommonJS, from everything to everything else. So we can do builds, and then Steel Tool does our automatically bundles a site and builds it, and also can plug in a file, which I'll talk about in a second. So let's talk about Tracer. All these projects, if you want, you can use them independently, and I suggest if you want to start using ES6, it's kind of cool to add these things to your workflows. So that's why I'm going to kind of go through the APIs for each of these projects, because if you want to use it, you'll kind of have an idea how. So Tracer, that compiles from ES6 to ES5. If I put array notation and stuff like that, which I probably should have done to make a cooler example, but it converts it to valid ES5 syntax. In this case, if I were to compile import $ from jQuery, it converts it to something like this. Tracer needs a runtime now as of 4.5, 0.045, but it converts it to basically CommonJS, right? Because that's what I wrote it out as. You can also make it transpile to AMD, which is handy if you're using AMD or CommonJS. Also, it creates an AST, which means basically it creates a, you can use it to parse ES6 syntax and then read kind of the data from that, right? You can see what it's importing and things like that in kind of a JSON object. Kind of like Esprima, if anybody's used that, it can be used for the same kind of thing. Although Esprima is way nicer. Use Esprima if you're doing those kind of things. Okay, so then ES6 module loader. This is what provides the actual loader, but it uses Tracer internally to do the transpiling, to figure out what dependencies are and things like that. So this just supports the default behavior, which is a loader constructor function and the default system loader with base URL and paths URL and the import function, things like that. I've got the URLs on the bottom right if you guys are interested in finding more out about these projects. System.js. This is where the money's at here. System.js takes the default polyfill and adds almost everything you need to have a client-side loader do what you want for a real project. So it supports different formats. It supports AMD, so you can have a file with AMD and it can load that fine. And these can load each other too. It supports CommonJS. It supports globals too, which in two different ways. You can have, it has this kind of API where you can kind of put in the file itself, in the strings, what the dependencies are and what it exports, or you can do that through the shim config, which I'll show in the next slide. So it supports the map config, which if you're familiar with require.js, that allows you to map a name to some other module. It supports basically what is require.js' shim config, which allows you to do that kind of shimming to make okay, well, if I load UI accordion, I want to make sure I load UI core and UI widget, because those are dependencies. Same kind of thing, I can specify the format. I want jQuery to load as a global, not AMD. But it will actually detect it. It'll actually do a regular expression when the file's loading to figure out if it looks like AMD, looks like CommonJS, or looks like ES6, which is really cool. It supports a bundles config, so that way you can bundle up all your scripts in a production, and it'll look for jQuery in bundle main instead of trying to load jQuery itself. So it also supports plugins, just like AMD plugins, except that the bang is put to the right, which I actually like a lot more than the left. I don't know if you guys are familiar with what I mean, but hopefully. Okay, so here's, so this is what a plugin would look like. This is what an example CSS plugin module would look like for written in CommonJS that would support a CSS. Basically, you make this work with CommonJS or System.js, you provide how the module should execute, and all I'm doing is creating a style, setting the text of the style to load source, appending that to the document, and returning you got to return a module. So if anybody loads foo.css, they get something, but they're just going to get like an empty object. Okay. It also supports, so you don't have to put the module name. It'll look at .css and assume you're trying to load a CSS plugin, which is, again, nice. So we took all of this and we've added essentially some things to make it easier to set up and to build. So you can build it into a single production file. And that's the Steel project, which I realized I did not change this down here. So Steel, we try to be as kind of dry as possible. Do not repeat yourself. If you load Steel, it'll load automatically ES6 module loader and System.js. You can provide it which is your main module load, but it does some things that are really nice. It'll load Steel obviously here, but it'll assume base URL is root because it knows, like, we typically have our components at kind of a root place of where our scripts are, although that's configurable. It'll also configure all the paths so it can properly load CSS and less, and then it'll by default import a config, right? It's kind of annoying if you use require.js a lot, like you always, at least we do, if you have a lot of different pages, you have to specify config for each one. This will load a config for you automatically, and then once that config is done loading, it'll import main.js, which is nice. So it also supports a few other nice extensions. The ext extension, so that you don't have to write out a big long module name here. You can just say, hey, if the .stash extension is found, you can just import, you can just write home.stash and it will tack on the bang can stash system for you. Because it drives me crazy in AMD writing out over and over again all the plugins, all the bangs. If I say .css, obviously load CSS. It also supports an environment, so it does different things when you're in production. If you configure it to load an environment, it just loads Steel and then just loads the main. It has a default location to look for the main modules bundles. So, and I said already, it supports less than CSS. Just drop in, no extra work. And then, okay, so that was what Steel does. And then finally, the Steel tools, this does progressive loaded builds. And this is going to be the hardest thing to follow, and I'm going to do my best to explain it. Okay, so let's say you had 4 different pages for your site. Home page, category, product, registration, and the dependency tree looked like this. Building this so you're making use of caching as much as possible, right? So you're not duplicate loading things as you go from one page to another page, is really great if you can accomplish that. But you don't want to load too many scripts, right? You don't want like a share nothing really approach, because then you'll load way too much, or you'll have like 10 scripts and that will load slow. So what Steel's build can do is it'll first group everything by what's kind of shared, like what's shared by everything, what's shared by 2 of 3 things, or 3 of 4 things, what's shared by 2 of 3 things, what's shared by just 1 thing. So it'll see that, oh, title, CSS, and jQuery are used by everything. I'm going to group that. And that's what's shared by basically everything, H, C, P, and R. Then it's going to notice, hey, cart is shared by 3 things. So I'm going to kind of make a bundle there. And then these 3 things, carousel, slider, CommonJS, those are all shared by category and homepage. And then it kind of gets to this point. But the problem is that if we just left it here, you would have to load 3 scripts, which actually isn't so bad, but let's pretend that loading 3 scripts is bad. Where it much be better to load 2 scripts. Because homepage, we have to load this bundle, which is shared by these 2 things, this bundle, which is shared by those 3 things, and the bundle that's shared by everything. So what it first tries to do is it starts trying to combine packages. So you can see here, try to move color and cart into the HCP bundle. And it will do is it'll figure out how much waste is added to each page. What happens is because homepage and category are going to have to load color, I think. They're going to have to load color, so they're going to have to load a kilobyte extra of waste. Product is going to have to load carousel, slider, and CommonJS. So that it's experiencing 30 kilobytes of waste. We just added 32 extra kilobytes of load time. So it'll try, basically, it'll greedily try almost every combination. It'll try this one next to instead combine cart with jQuery and title. And then what that does is it only adds 20 kilobytes of extra waste to registration because now it has to load the cart. And that's better than the other. Combination. So it'll try to perfectly optimize your site without you thinking about it. Everybody right now, they like spend a bunch of time like, oh, I know I use jQuery, oh, I know I use Angular, and I use these few widgets on almost everywhere, so I'm gonna combine them myself. But then there's this horrible thing that's like, oh, but I use this on 3 of 5 pages. I use this one on 2 of 4 pages. This system figures, good thing my wife's not here. This system figures it out for you, and will like make your perfect page load times. Like you could never do it better than it can. So the API for this, basically you just tell it where your config file is, which signals your root folder and your path, and there's a bunch of different options, so you can bundle scale and things like that. So I'm going to show an app, it can also do pluginification, which means like compile, remove all the AMD, CommonJS, and everything else, right? So you can download it without needing those. I'm going to show a very ugly example app that I made because I spent all my time this weekend getting it working and not making it pretty. Why won't this? Come on, Firebug. It won't let me drag it. And we will do this in Chrome. Okay. So here's an example app that is going to progressively load different pages. Show network. Okay, so right now it's in development mode. So it is just loading like a ton of things. And as you can see, it progressively loads more of the app. If I clear it, I can log in, and then and as I go to different pages, there's resources. As I go to different pages, it will load what's on that page. This is loading Bootstrap. and then this loading jQuery UI, and edit jQuery UI widget, home, and the back button works, and so forth. It's pretty, like, this is the basics for like a progressively loaded app. Like you start on the home page, you actually wait till you log in, then goes to the page, and then you can, as you click back and forth, it'll load what's needed, and then once that's loaded, actually run your code. You can see it just loads a lot of resources here. So what I can do is do that same kind of process to figure out what's shared between home, jQuery UI, Bootstrap pages, and we'll build that like perfectly, basically. Way better than you could ever like assemble it yourself. So if I run my build, which I can do with grunt.
Hey Justin.
Yeah. Are
those separate pages, or is that a single page app?
This is a single page app that's progressively loaded.
Okay, so when you say pages, you don't really mean pages.
Yeah, but it can work with pages. But right now it's progressively loaded app.
Okay.
So just to show it going here, I'm going to grunt. Okay, so now you can see here what it did is it put everything that's needed by like the first page, like, you know, just to get the routing working. Put everything there together. Oh, this uses Uglify, which I think even has better compression than Google Closure, but not under advanced. And then so it bundled what's just needed by jQuery UI, what's needed by Bootstrap, and then it starts doing like the combination bundles, which are in here. Oh, there are no combinations in this one because they've flagged it because there's not enough depth in shared. But anyways, I can put this in production. Now when I load my page, oh, thank you. Now when I load my page, you can see here it's loading. Okay, so now you can see here it's loading the main module, which kicks off the routing, and just the login JavaScript, which is needed for this. And as I log in, it loads the home page. If I go jQuery UI, it loads jQuery UI, it's CSS. And if I click on Bootstrap, it should load Bootstrap. Bootstrap, it's JavaScript and it's CSS. It's just loading what it needs, even if those have dependencies themselves. This is not actually Bootstrap.js. This is I have a Bootstrap component that kind of renders that. This is a CommonJS thing. But I basically have a module. This one is AMD that draws that kind of Bootstrap control on the page. And I have a, I have a home that is another component. This one is, so Bootstrap is require.js. This is CommonJS, and this is ES6. And they all just work all together like that. So that is it. Any questions? Yeah.
Does this potentially add a lot of overhead to your startup if you're transpiling and loading all those transformations before you actually boot the app? For a larger app with lots of code that could...
So in production, it's already transpiled.
Okay.
Like, that's what that build does.
Oh,
it converts it all to something. Actually, it converts it all to AMD. So you can actually use like, well, I haven't got it totally working yet, but the plan is to make it so you can load it with Almond.
Oh, nice.
If you need to, if it's all like one file. I don't know if Almond can like do progressive loading. I've never tried that. But you can use require.js, which is smaller for now, right, than this is, because this still has to include the polyfill.
Okay. Cool.
Yeah.
If you were going to do this in another app, how would you handle flipping between production and non-production? Would you do that
So
as part of your build? Or?
Yeah. Like you saw, I ran grunt wash, and then I would just, so sometimes what we'll have is a, dev dot HTML that doesn't have the end equals production, and our other one, like index.html, will have it. Yeah.
I've got another question. Kind of going back to my earlier question about the cross-domain stuff with the new module syntax. If you can load arbitrary content, is it limited to scripts, or could you load any resource from any domain and then do whatever you want with it?
So the plugins, I don't think, like, it's all that the base is set up to do is load scripts. So anything that you added to like load an image or do something trying to get like away cross domain issues, you would have to write that code yourself, and that would hit the APIs that don't allow you to do that anyways. Do you get what I'm saying?
No, so I guess I'm wondering, like, if I wanted to load, like, this is a bad example, but like a CSS file from an external domain that I don't have cores access to or anything like that.
Yeah, that would not work.
Okay.
Well, no, sorry. You can write a plugin that will like inject a script or a link tag, and then it will work.
Okay.
But you have to kind of, like, these plugins, CSS, less things like that, you have to implement that yourself, those plugins. That doesn't come with the system and module loader. And because you're implementing that yourself, you're only given, like, what the browser already provides you. So it's not like it specially can escape the cross-domain things.
Okay.
Basically, restrictions. Yeah.
So I guess you kind of answered this with your last answer, but is there any future plan or idea that will allow you to also do the same type of dependency management for CSS? You know,
It does do the same dependency management for CSS, and it does it with all resources.
Okay.
So I'm actually loading even templates as plugins. So this is like a stash template, and I can load that directly, and it gives me just a function that, when called, renders that template.
So, but it doesn't. Will it also do the because part of the advantage of this is that it will bundle groups of code together.
Yeah.
Will it do that for CSS as well?
That's
other
what I
than
was just saying. Yeah.
Yeah.
So it actually bundles. Like I might not have shown it. Oh, here now it's working. I like how this. It's so much, to me, easier to read what resources it's loading in Firebug than. Still doing the same thing. Well, let me refresh and see. Oh, that's really good. You can see here it's loading the CSS, and this is like the bundled CSS for everything that like kind of the Bootstrap page needs.
So that's not just Bootstrap's own CSS. That's actually
in this case it is. But if I put in Bootstrap.js right here and stole something like a different CSS file, that would be combined with Bootstrap CSS.
Okay.
Another cool thing I forgot to show off is, yay, ES6 syntax. Makes me happy. All right, I could just add it to like objects and kind of the fat arrow syntax. I didn't get a chance to use like array comprehensions or anything like that. Yeah.
But you're using this with code that's hosted on a CDN. You still have the same benefits. Like you can import like parts of a library like that.
Yeah, so we haven't added the ability to do package, like, so the old version of Steel supports package false, which basically says don't put jQuery in that build. So when you go to load the app, we'll load your production, but then load jQuery on the CDN or something like that. That's actually not hard to add back. We just haven't done it yet, but that will happen.
How fast does the transpiling take, like in development mode?
In development? Oh, well, most of it's actually, right now I'm loading the non-minified version of Tracer, and that's like 90K or 900K.
Oh, wow.
So it takes a while just to load that. The minified version would be a lot better. It's pretty quick, like the actual transpiling. It's more Tracer is the, just loading that is the, and that takes like an eighth of a second on a local connection.
Is it parsing the whole script? And how does the tracer
Yeah,
part
Tracer
work?
just basically parses this whole script and then builds it.
It seems like it would be slow. It's crazy that it's that
But
fast.
if you think about it, your browser is already parsing this script. You're just adding another one.
Yeah.
We do plan to support like watched faster builds. So if you just change this file, it's just going to update that one place inside the production build. So, if you want to do something like Browserifies watches, so it just builds on the fly anytime you do a key change or save your file, that should be very straightforward to do. So,
How soon would you realistically do this? Like,
So-
any idea?
we're going to try to start using this in like on a project now. But that's what I was saying in the beginning. I think that you really might not want it in production until the spec has been finalized. At least like you as in someone who can't just immediately change it to make it work on the spec, or like can handle breaking things like underneath you. That's what I'm saying. I think once the spec closes, I would actually start using it then, because by the time the polyfills are really good, I think that the implementations in browsers after the spec gets solidified is not going to take very long, and you probably like start ahead of the game. And the good thing is this will eventually be much smaller than AMD because it's provided by the browser, right? If you're just using ES6 syntax, you don't have to do anything else, right? There's no library that you have to load. You just have to build. It's really going to be, I don't know, an awesome day.
All right, thank you.